Hello everyone, my name is Sahil Khose and today I'll be presenting our work SkyScenes, a synthetic dataset for aerial scene understanding accepted at ECCV 2024. This work has been jointly done with my co-authors Anisha Pal, Ayushi Agarwal, Dipanshi, Judy Hoffman and Prithvijay Chattopadhyay at Georgia Tech. In this paper, we try to bridge the synthetic to real gap in aerial images. Real images on this slide you vivid, the dense annotations can take hours to annotate. For example, in UAVID, it takes more than 2 hours to annotate every 2K image in the dataset. And the perspective is limited due to equipment and geography. Whereas in synthetic data, we have controlled heterogeneity, which has access to dense and multimodal labels instantaneously. You can also choose height, pitch, and various different parameters for image curation. Hence, we introduce SkyScenes, a synthetic dataset controlling all these parameters and generating a dataset which has weather and daytime variation and has dense annotations across semantic instance and depth, and many more multimodal annotations can be added through our pipeline. We have various map variations through urban and rural layouts. We also have height variations and pitch variations. The weather, daytime, height, and pitch variations are controlled variations, which means that all the actors in the scene are precisely located in the same spot, but we have data which is simulated and collected over different variations of these. Hence, our dataset has 33.6 thousand aerial images, which has semantic instance and depth annotations across 28 classes. It has 8 distinct geographical layouts, 5 weather and daytime conditions, 3 altitude conditions, and 4 pitch variations. We also put specific efforts to develop algorithms to improve the rare class proportions in the dataset. SkyScenes has a better representation of tail class compared to other synthetic and real datasets. And we also see a huge boost in performance on tail class performance because of this. We also use we also use SkyScenes as a diagnostic test bed, which means that if you train a model in rural, uh, you can test rural or urban, you can test it on both and see how the performance goes. And you can use it as a diagnostic framework across different times of day, weather conditions, etc. Our zero shot real world generalization performance is is much better than other synthetic counterparts out there. We show our model performance across 3 real-world datasets, UABIT aeroscapes, and ICG drone, and models trained on SkyScenes generalize well to all of these. They also generalize well when trained on SkyScenes versus other synthetic counterparts, and this performance is particularly pronounced for tail classes because of our inbuilt algorithms. We also show that synthetic plus real training, especially when it's low shot setting, we get huge boosts in performance. We showed this experiment across explicit joint training or implicit via fine tuning. Synthetic, our synthetic dataset SkyScenes is available on Hugging Face. The paper and code links for generation and data curation are provided on this slide. Please feel free to check it out, and thank you.